So before we start our chapter, algebraic expressions, we're just going to go over some vocabulary terms that you will continue to see. Now, these aren't vocabulary words that once you're done in 6th grade, you will never use or see again. You will continue to use these. Our first term is variable. A variable is a symbol that represents an unknown value, so something that we don't know yet. We usually use a letter to represent these values. Here I have quite a few expressions. In these expressions, we're going to identify the variables. Now, if you know what a variable is, you feel free to pause the video and answer them and then check them when you're done with the video. So we have 72x plus 3w. If I'm going to identify my variables, what I'm looking for are the letters. Well, here I have an x and I have a w. Each letter represents a different unknown value. X is a variable and w is a variable. Here I have 12z minus 5. Well, z is my letter that represents an unknown value. Here I have 4s divided by 5 plus r. Well, I have s, which represents an unknown value, and r, which represents another unknown value. In this example, I have x, y, z, and d. Each letter represents a different unknown value. In my last example, I have 4y minus u plus 13. So I have a y that represents an unknown value and a u that represents another unknown value. When we're dealing with variables, it's important that we understand when we use lowercase letters and when we use capital letters. In the current chapter, chapter 7, and in chapter 8, we're going to be using strictly lowercase letters. When we start using capital letters, different capital letters have specific values or reasons for them. Such like if we look at a capital A means area, or capital C means circumference. So it's really important that right now we only use the lowercase letters. And as we move on chapters, we'll start looking at the capital letters. But for now, we're going to stick with the lowercase. The next vocab word we have is algebraic expression. So an algebraic expression is just a phrase that contains numbers, operations, and variables. So what I think is the most important part of this definition is the variables part. Because if we only have numbers and operations, then we're looking at a numerical expression. The variables is what makes this an algebraic expression. And what we know is an expression does not have an equal sign or an inequality. So if either one of those are in our math phrase, we know it is not an expression. We're going to move on to some examples. Here I have 12x plus 9. Well, I see I have a number 12, a number 9. I also have a variable of x and an operation of addition. This expression contains all three components of an algebraic expression, which means this is an algebraic expression. Here, when I look at 52 minus 16, I have two numbers and I have an operation. I do not have a variable, which means this is not an algebraic expression. This is a numerical expression. My next example, I have 61t minus 5 equals 34. Here I have numbers, I have an operation, and a variable. But I also have an equal sign. And I know if there's an equal sign, I am looking at an equation, not an expression. Here I have 4 divided by 7 minus 3w plus 6. This expression contains numbers. I have a variable of w, and I have 3 different operations. This expression contains all 3 components, which means this is an algebraic expression. Lastly, I have 5f plus 7 is greater than 62. In this example, I have an inequality symbol. That tells me this is not an algebraic expression. An algebraic expression, or an expression in general, does not include an inequality symbol. Our next word is coefficient. A coefficient is a number multiplied by a variable. Before we get into some of the examples, I think it's important that we understand what some of these examples are talking about. So if we have 2x here, this means 2 times x, which means I have a total of 2 x's. So I have x plus x. If I have, let's say, 4y, what this means is y plus y, that's supposed to be a y, plus y plus y. Because if we think about it, we know that repeated addition is the same thing as multiplication. So if I have y plus y plus y plus y, that's the same thing as having 4 y's. So I have 4 times y. Something to keep in mind is if there's a variable with no number in front of it, that means it has a coefficient of 1. So if I have the variable x, I do have a coefficient. My coefficient is a 1 because x is the same thing as 1x. Just in math, we tend to not write the 1. I like to refer to the 1 as the secret ninja 1 because it's there, we just don't see it. Something else to keep in mind is when we're identifying coefficients, we have to make sure that we keep the sign that is in front. So let's say I have 6 plus 4w. Well, a coefficient is a number multiplied by a variable. So here I have 4 times w. So I know this 4 is my coefficient, but if I need to figure out whether it's going to be a positive or a negative 4, I have to pay attention to the symbol in front. This tells me that my coefficient is a positive 4. But if my expression was changed to 6 minus 4w, this 4 is my coefficient, but it's not a positive 4. It's going to be a negative 4. So now we can move on to some examples. Our first example is 72x plus 3w. So a coefficient is a number multiplied by a variable. So this is 72 times x. So my 72 is a coefficient. And then I have 3 times w. Well, the 3 is being multiplied by the w, which makes this a coefficient. I move on to my next one, and I have 12z minus 5. The 12 and the z are right next to each other, which tells me this means 12 times z. And I know a coefficient is a number multiplied by a variable. So 12 is a coefficient. Here I have a minus 5. This 5 is not being multiplied by a variable, which means it is not a coefficient. My next example, I have 4s divided by 5 plus r. My 4 and my s are being multiplied. So what is the number being multiplied by the variable? 4. 5 is not being multiplied by a variable, so it is not a coefficient. I have to be careful that I don't move on from this. I have an R here. It's very easy for us to say there is no coefficient and walk away. But we have to remember that in front of this variable is the secret ninja 1. So the coefficient for this R is a positive 1. When we move on to our next one, we have negative z plus 14 minus 5d. Again, it's an easy mistake to say that this has no coefficient. But I have to remember in front of this z is the secret ninja 1. And what type of 1 do I have? Well, I have a negative 1. So my coefficient is negative 1. 14 has no variable being multiplied, so I can leave it alone. Then I have a minus 5d. D is being multiplied by the 5, so I have another coefficient. But is it a positive or a negative? It is going to be a negative 5. For the last example, we have 4y minus u plus 13. The 4 is being multiplied by the y, so I have a coefficient of 4. And I can't forget, in front of this u is my secret ninja 1. And I need to take the sign in front, so I have a negative 1. These are all my coefficients. Our next vocabulary word is constant. A constant is a fixed value, so this value does not change. The way I remember it is a constant is a number that stands alone, so it is constantly alone. Just like coefficients, we have to pay attention to the sign in front. That's going to tell us whether we have a negative or a positive number. We're going to look at the same examples, but this time instead of looking for a coefficient, we're going to be looking for the constants. So remember, a constant is a value that stands alone. Here I have 72x plus 3w. Neither my 72 nor my 3 are alone. They are both being multiplied by a variable. So this one has no constants. I move on and I have 12z minus 5. 12 is being multiplied by the z, so it is not alone. But here I have this 5 and nothing's being multiplied by this 5. So that tells me this is a constant. But I need to make sure I'm looking at the sign in front to tell me what kind of 5 it is. In this case, my constant is a negative 5. Here I have 4s divided by 5 plus r. 4 is not alone, it's being multiplied by that s. 5 is not being multiplied by anything, and it is a positive 5, so that is a constant. I have no more numbers that are standing alone. Move on to my next one. I'm looking and I'm saying, do I have any numbers that are standing alone? Z is a variable. 14, is there anything being multiplied by 14? There is not. So I have a positive 14. Here I have a negative 5, but it's being multiplied by the d, so this is not a constant. Move on to my next one, 4y. That's being multiplied by y, so that is not a constant. I have a variable, this is not a constant. And then I have a 13, which is being multiplied by nothing. So I know my constant is a positive 13. Looking at these examples, you might notice that each expression only has one constant. That is not always the case. Sometimes you'll have 2, 3, 4. You could have 10 constants. Okay? Just these examples happened to only have one constant. Our last vocabulary word is the word term. A term is a part of an algebraic expression. The way to identify how many terms are in an expression or what the terms are is each term is going to be separated by an addition or a subtraction sign. Just like constants and coefficients, it's important to pay attention to the sign in front of each term. So let's take a look at some examples. Here we have 72x plus 3w squared. In order to identify my terms and how many I have, I tend to just draw a line wherever I see addition and subtraction signs. So this tells me that 72x is my first term, and this is a positive 3w squared. That is my second term. Here I have 12z minus 5. Going to draw a line wherever I see addition or subtraction. My first term is 12z, and my second term is a negative 5. Here I have 4s divided by 5 plus r. Going to draw a line wherever I see an addition or subtraction sign. Again, I only have two terms. My first term is 4s divided by 5, and my second term is a positive r. Here I have negative z plus 14 minus 5d. Going to draw a line wherever I see addition or subtraction. In this case, I have three terms. My first term is negative z. My second term is a positive 14. And my third term is a negative 5d. Moving on to the last example, I'm going to draw a line wherever I see subtraction or addition signs. Again, I have three terms. My first term is a positive 4y. My second term is a negative u cubed, u to the power of 3. And my last term is a positive 13. This is how I find the terms.